Okay. Today I am discussing about a problem from Pathfinder physics by ARVIND TIWARI and this. But before discussing the solution of that problem I should discuss earth theta coordinate system. What is the velocity and acceleration and how the expression look like. So this is our y-axis, x-axis. Basically, in earth theta coordinate system, we do not use y-axis, x-axis. We use initial line. This one is the initial line. Sorry, this one is the initial line, and this one is this. But in earth theta, we call this as pole. Okay. So there is a curve given by r equals f theta, and B is a general point which is moving along this curve. Okay. And the vector joining the pole and the B is called as r bar, and the unit vector along r bar is represented as er cap, and unit vector which is perpendicular to r bar is represented as e theta cap. Okay, and the coordinate of B, we can describe the position of B by r and theta, corresponding r and theta. Okay, and theta is the angle made by this r with initial line. So here we can write e r cap as like this, and e theta cap like this, and r bar can be represented as the modulus of r times its unit vector. Okay, so velocity v bar equals to dr d theta. So r times d er cap dt plus er cap times dr dt. So er cap times dr dt plus r e cap theta and d theta dt. But so here you should understand how d e r cap by dt equals to minus sin theta I hat plus cos theta j hat theta dot. Okay, and this is nothing but e theta cap theta dot, and this is written here. Okay, so this is not in our part of discussion. So this is the expression of v, velocity. And what is the expression of acceleration? Acceleration is ever which is dv by dt, and there is a simple calculation, but you should know that let me tell here, de cap theta by dt equals what? Minus cos theta I cap minus sin theta j cap times theta dot, and that is equals to minus er cap times theta dot, and this result is used here. This result is used here. So this is the expression of acceleration, and this term is called transverse component or normal, or tangential component of acceleration, and this term is called normal or radial component of acceleration. And this is our important two formula, velocity and acceleration. We should move to the problem. And the problem is a figure is given, a curve is given, and this is something like point P is here. Let me use red pen to make it more bright. A point P is here, and the position vector r bar, velocity vector v bar, and angular position theta of a particle traversing a path AB are shown in the figure. Here phi is the angle made by velocity vector with the positive x-axis. Which of the following statement is correct? So this is the diagram. This angle is theta. Actually this line and this initial line are parallel to each other. So this angle will be also theta, because this is theta. And this total angle is phi. Okay, this total angle is phi, and I have drawn two unit vector here, and this is v bar, this is v bar. Okay, this is not the v bar, this is v bar, and this angle is pi by 2. This angle is pi by 2. So what will be this angle? This angle will be phi minus pi by 2 plus theta. Phi minus pi by 2 plus theta. And that is phi minus theta minus pi by 2. And along E theta direction, the component of v bar is v cos theta, phi minus theta minus pi by 2, and this can be also written as pi by 2 minus phi minus theta. And we have compared the E theta direction of velocity here, and we get that result. And also we have compared the ER direction of velocity here, and we get that result. We have the velocity expression is like that. By differentiate it with respect to t, we can get the acceleration of the particle here, and you can compare the answer. I think A is the right one, and here is some about acceleration. You can compare it from this result. Thank you.